That worked. The final price is 480. That's correct. What is this algorithm? I don't even fully understand what I wrote. I'm going to be honest. I think that's right. 31065. That's right. This algorithm works. I don't know what I just wrote. Day 13, Claw Contraption. Next up, the lobby of a resort on a tropical island. The historians take a moment to admire the hexagonal floor tiles before spreading out. Fortunately, it looks like the resort has a new arcade. Maybe you can win some prizes from the claw machines? The claw machines are a little unusual. Instead of a joystick or directional buttons to control a claw, these machines have 2 buttons, labeled A and B. Okay? Worse, you can't just put in a token and play. It costs 3 tokens to push the A button and 1 token to push the B button. Oh, this sucks. Okay. With a little experimentation, you figure out that each machine's buttons are configured to move the claw a specific amount to the right along the x-axis and a specific amount forward along the y-axis each time the button is pressed. Okay, cool. Each machine contains 1 prize. To win the prize, the claw must be positioned exactly above the prize on both the x and the y-axes. Cool. You wonder, what is the smallest number of tokens you would have to spend to win as many prizes as possible? Okay, you assemble a list of every machine's button behavior and prize location, your puzzle input. For example, button A. Okay, so button A is the one that costs 3 tokens to push, and every time you push it, I'm guessing you move 94 in the x direction and 34 in the y direction. And B is the one that's a third of the cost, and every time you press it, you move 22 in the x direction and 67. Oh, and the prize is at these coordinates. Okay. All right, I'm following. Okay. The list describes... So, are some of these going to be possible? Are these all going to be possible? I'll keep reading. The list describes the button configurations and prize location for 4 different claw machines. For now, consider just the first claw machine in the list. Pushing the machine's A button would move the claw 94 units along the X and 34 units along the Y. Okay, cool. That's what I thought. Pushing the B button would move the claw 22 and 67. Right. The prize is located this. This means that from the claw's initial position, it would need to move exactly 8,400 units along the X-axis and 54 along the Y. Okay, to be perfectly aligned. The cheapest way to win the prize is by pushing the A button 80 times and the B button 40 times. This would line up the claw against the X-axis because 80 times 94 plus 40 plus... Oh, okay. Equals 8,400. Oh, okay, so you have to line up the X, you have to line up the Y, and every time you press a button, this is how much it moves. Okay, this makes sense so far. Doing this would cost 80 times 3 tokens for the A presses and 40 times 1 for the B presses, totaling 280 tokens. For the second and fourth claw machines, there is no combination of A and B presses that will ever win a prize. Okay, cool. That's what I was wondering. For the third claw machine, the cheapest way is by pushing a total of whatever. So the most prizes you could possibly win is 2. The minimum tokens you would have to spend to win all 2 prizes is 480. Okay. You estimate that each button would need to be pressed no more than 100 times to win a prize. Okay. So in order to win a prize, I don't need to press the A button more than 100 times, and I don't need to press the B button more than 100 times. Okay, so this kind of puts a limit on if I want to brute force it. How else would someone be expected to play? Cute. Figure out how to win as many prizes as possible. What is the fewest tokens you have to spend to win all possible prizes? Okay. We're getting here. Okay. Let's grab this. This will be our input. Let's make a directory for it. We're in 2024. Make dir day 13. Cool. Vim example input. Cool. Now I will go through and get the real input, and I don't share this part because I'm not supposed to share it with y'all. Whew. How's everyone doing tonight? Cool, we got part 1 as a script. And what are we going to do? We're going to read in the puzzles. We'll read in the button A, the button B, and where the prize is. Okay, so let's try this. We're going to read these line by line. And we should get exactly that. Neato. Works good. So we should grab the information that we need out of the puzzle. How should we parse this? Okay, here's what I think we'll do. I equals 0. This will count every single line we're on. And then we can do a case on I. Mod 4. Because there are 4 lines that we care about. Ooh, it's raining hard outside. All right. So this will do nothing now. All right, so let's pull the information out. So if we're here, then the line is button A. This is button B. This is prize. And this is nothing. So that's how we're parsing it 4 lines at a time. So when it's button A, what does that look like? It looks like this. We need to parse this. We need to get the X and the Y. So we just need the X plus number, the Y plus number. Yeah, let's just do a simple regex. Button regex equals button. Let me grab this as an example. I like to do this when I'm writing regex. I like to put the example up here so I can know exactly what I'm trying to match for. Button AB colon X plus, and then in here will be some number, and then Y plus in here will be some number anchored at the end, and that's the regex to parse a button press. So we'll get the matches for, actually we'll just do this. I think we can do line, button re, exit 1, because this shouldn't fail, this should always work. And if this works, we should echo rematch. Let's just grab 1 and make sure it works. Let's just do this. Didn't work. Wait, did it exit 1? Okay, so it didn't match that regex. I don't want that. Why didn't it match? It looks like it should match. I tried using this because someone suggested it on a different video, but let's just use the old tried and true 0 through 9. This might not be the problem. In fact, this probably isn't the problem, but let's go ahead and just, rule that out. Yeah, that wasn't the problem. Is it these plus signs? Do these need to be escaped because of trying to do it one or many times? It's the plus signs. Oh yeah, YouTube chat, plus a special. Yeah, we'll get there. Cool, so now we match that. Let's go ahead and just do this right out the gate. I'll make a nice little fatal function, and that way we can just say like fatal regex fail, something like that, just so at least we have like some idea. So now we can do x equals this, y equals this, cool. Now we have to figure out how to store these. Oh yeah, hopefully I put dollar signs right. Cool. Now, how do I want to store these? Because I need to be able to store the data in a way that makes sense. Kind of want to store them with a comma, or a pipe between them, or a comma. Yeah, comma probably makes the most sense. So let's do this. Let's say A equals this, B equals this, and P equals this for A, B, and prize. So we'll do A equals X comma Y. That way we can do the same thing down here. A little bit of copying and pasting code, but, you know, that just proves we're enterprise ready. The Go. Yo, what's up, Ox? How you doing, man? Nice to see you here. Yeah, I'm trying out Twitch. I got the YouTube stream going, and now I got Twitch going on as a side thing. I figure I'd give it a shot, see what the people think. Try to grow my audience a little bit. So this is B now. Cool. Awesome. So then when we get down here, this is where we have A and B, and then we can reset everything in this part of the code. Oh, because I'm printing it out twice. Yeah, that's why there's spaces. Let's just do the machine here. So this should print 4 times. 3 times? Should be 4 times. Oh, because there's not a trailing new line at the end. Yeah, that's okay. What we should do is we should do the committing here. Okay. There's not guaranteed to be that trailing new line at the end. So we'll do the... We'll commit after we process the prize. Process prize, commit results. So we'll do this all in the same breath, basically. So now if we run this, cool, now we get 4, which is what we expected. Cool. So now we know what the A and B buttons are for those, so 94 and 34. Let's just do the... You know what? Let's make our lives easier. Just for now, we're just going to do the first loop. We're just going to do the first claw machine. That's what we're going to do. So of this, we're only going to look at the first 3 lines. That's what we're going to care about. And if I run my script, yeah, okay. So 94 and 34 is what it gets, and that matches 94 and 34 here. Awesome. These are plus. Are they always going to be plus? Or is it possible that a claw machine could move some backwards? Let me see. It's not possible that it would... Minus isn't going to be in there, right? Okay. Yeah, I would hope not. Cool. So that's what our first machine is. What's the next thing we have to read? We have to read the prize. Okay, so prize is simple. Regex. Prize just looks like this. Cool. That should work. And then we just do the exact same thing here. So now let's just do this. Regex fail. Hey, look at that. How beautiful. That makes sense. Cool. Awesome. Now we can describe a machine. So now that we have this information, what we should do everything in a function because, and here's why I'm saying this, just looking at the problem, every machine can be tested simultaneously. No machine relies on the machine that came before it. So if we have to start threading things and doing things simultaneously, we won't have a problem with that. So let's go ahead and do every single thing in its own function. So let's say like, I don't know, check machine. We'll give it the A, we'll give it the B, and we'll give it the prize. That is how we'll do it. And each one will be in the format of number, comma, number. There we go. So now we can make a function called check machine. I'm going to open parentheses here, so every variable it creates will be in its own scope. So we can just do, I'm still going to do local, just force a habit. local B equals this, local P equals this. There we go. We have our data. So now we can read everything we need. So AX, AY, BX, BY, PX, PY. So the X and the Y coordinates of the A, B, and prize. So IFS equals comma, read dash R, AX, AY, read in from A. Now we just change these to B, and then we just change this to P. Very, very simple. Echo checking machine. We should give these identifiers later, but don't even worry about that. Checking machine, echo AX, BX, no, AY, BX, BY, and PX, PY. Hey, look at that. We were able to get the data and reconstruct it. So we have everything we need in the function that we want. That's wood. That's good. Enough dilly-dallying. Let's figure out how we're going to do this algorithm, because I put zero thought into this. Oh, and I'm scared. All right. So every time we push a button, we're going to just use this first example. We go 94 in the X direction. And actually, we could just focus on X and then Y. So we go 94 in this direction, we go 22 in this direction. How many combinations of those can be 8400? So put a different way. If our answer is 8400, we have to figure out what problem led us there. And that problem is going to be X times 94. Let me try and write this out. I'll write out what I'm thinking. Just gonna make a notes.txt here. So for the first prize we have, let's grab the first 3 lines from the example input. There we go. This is our first puzzle. So down here we know that we need to press the button A some number of times. Okay. So pressing the A button Yeah, the A button is 94. Okay, I think I have it. I think I have it. We're going to use random variables. We're going to use I and J because I can't think of better variables. I times 94 plus J times 22 equals 8400. This is the math that we're trying to solve. And this just gets us the X. The Y... And we'd have to look for the overlap between these two. Oh, this seems like a graphing problem. I remember doing stuff like this in high school, which is bad. When an advent of code problem reminds me of high school, I know I'm screwed. All right, so this is what I'm thinking. I times 94 plus J times 22 equals 8400. We have to find all the numbers that satisfy this, and then we have a cost function at the very end, which is, you know, an A button press costs 3 times as much as a B button press. So it's not just a matter of finding, we have to find all the ones that are valid, and then we have to figure out which one is simpler, or which one costs least. All right, so here is the math that I think we need to solve for. So we need to find every possible value of I and J that work for this. And the nice thing is our stopping condition is we can't ever go above 100. And also, once we get above 8400, we know we've hit the end. So, do we just brute force this? I mean, is there a way, let me think. Is there a way to mathematically represent this? Because basically, because this is like linear algebra, isn't it? This is like A times something plus B times something equals C. And then you would just move C over here. You would just graph this, right? Oh my god, I can't remember high school. Like, when I think back to high school, I just think of, like, talking to girls. I don't think about math. I'm gonna be screwed here. Let's try the brute force method just to get an idea of how long this is going to take. So try find all valid combos to get to X. Okay. And we're just going to make stuff up. It says 100. It shouldn't take, I think it says it shouldn't take more than 100. So I'm looking through the exact puzzle. Where did it say? It said 100 somewhere in the puzzle, right? Yeah. No more than 100 times. So no more than 100 means that it has to be less than or equal to 100. I++, do, done. All right, so let's see what this would look like. If we were to brute force this, the math would be, let's see. Something like this is what I'm trying to accomplish. And this is, I anticipate this is going to be ridiculously slow. But I just want to see if this can actually get us an answer that we can work with, so we can work out something useful here. So, let's do left-hand side equals, we'll take the left-hand side of the equation, which is I times AX plus J times BX. We don't need this because of order of operations, but I like it. And then right-hand side equals PX, which is the prize. If left-hand side equals right-hand side, then echo match. Let's see. A I times B J times. I have no idea how long it's going to take, but let's see how this works. Oh. Is that not that? Okay. I don't know what to do with this information yet. So that matched 69 times and B 87 times. So if we pull open the puzzle, let's see. Where was the first answer? B 40 times and A 80 times. Okay, so that's one that came up. Cool. We managed to find that. Now we just have to run through, do the Y, find the overlap, and then find the cheapest. We're getting there. Oh my god, this might actually be doable, because math is decently fast in Bash. We could probably abstract this out into a function, but for now we're just going to duplicate code because there's only an X and a Y. So I don't care if it's just duplicated once. There we go. So we'll say X match. Why did I quote this so weird? Match. Okay. Okay, cool. With the overlap, it's 80 and 40, so we already know that's the answer. Okay, so we should store the ones that are valid, and we're going to use an associative array. Here's how we're going to do it. When we have a valid match here, we are going to set I, comma, j to 1. Here's what we'll do. We'll increment it. And then when we have a valid match down here, we'll increment it, and then we'll loop through each one here, and for everyone that's 2, meaning it was valid for both, that's where our overlap is. So what we'll do is we'll go through, find those that were valid in both. So we'll loop over all the keys of valid. for key in valid, do, done, value equals valid key, value equal to, then this one was valid for X and Y. Cool. Then we'll echo, yay, it was key. So let's go ahead and try this logic. So what I'm going to do is I'm going to loop through all the X's, figure out what's valid, loop through all the Y's, figure out what's valid, and for those that are valid for both. Yay, we got 80-40. And for the first example, I know that's right because that's what it said on the website. To test, here's what we'll do. We'll make an array. And now that we know that this one was valid, we'll push that into the array. That's what we'll do. Echo found valid button combos. Let's bring this out into a variable. We found that many button combos. If len equal to 0, then return. This is impossible. Otherwise, test to see which one is cheapest. And which one? How do you find out which one's cheapest? Probably the one that has the least number. Well, I guess we just add up the score. We just calculate the score and then we do it. Yeah, let's do it. Let's see. Test to see which is cheapest. Okay, so we have to do the price calculation. So the price calculation is, I think it's 3. It's how many times you had to press A, and how many times you had to press B, and how many times you press A, I think is times 3, if I'm correct, right? Yeah. What's the best way to do this? I think we should make an associative array of the price. Can there be multiple things that have the same price? Well, it doesn't matter if there's multiple things that have the same price, does it? No, it doesn't. Yeah. We just need the lowest price. We don't actually care what... Oh, wait, yeah, we just need the lowest price. We don't actually care which one it was. Oh, so just... Yeah, okay. Yeah, so let's loop over to test for valid in to test, do, done, read-r, AB from to test. Cool. And now calculate out the price is A times 3 plus B. That's the price. If dash Z lowest price. So if we have nothing set as the lowest price, then we do price, then we set it initially. We just assume this one's the lowest because it's the first one we've seen. Elif price is less than lowest price, then lowest price equals price. We could combine those into one if statement, but I don't actually care to do that. And then when we get down here, echo lowest price was lowest price. Okay, so this says the lowest price was 120. Now when we go here, we can see that A button 80 times, B button 40 times. Yep. Doing this would cost 80 times 3 tokens for for the A presses and 40 times 1 for the B presses, a total of 280. Okay, well, we're a little bit off. So let's figure out why. Let's figure out why we are off. A times 3 plus B. $80.40. Oh. I didn't put a comma there. 280. We got it. Beautiful. So now, if we take out that part that limited it, if we take out this break, we should go through and we should do all 4 puzzles. Okay. We only did 3 puzzles. Right? Am I crazy? Did something eat standard in? Let me look at the puzzles real quick. What do we check? 26, 67, 21. That was the next one. Oh, tracking machine down. Oh, we never printed the double hyphen. That's why. This one had 0 valid combos. Then this one had a lowest price of 200, and the other one had 0 valid combos. So if we look back at our puzzle, okay. For the second and fourth claw, there's no combination that worked. Awesome. And for the third claw, we have 200 tokens. We're right. We got the answer there. Oh, so we need to add them all up. That's what we had to do that we are not doing. So now that we have all the lowest prices, we just need to add them up. Yeah, this isn't going to work. Because we need to add them all up, we need to do it like this. Let's not put them in their own thing, but let's just be really good about how we call things. Yeah, let's be really, really good about how we do things. Okay. Okay. I think we're good here. Now we can just do this. We can do total final price down here. And then we can go down here, final price plus equal lowest price. And this should equal 480 at the end. Oh, we should probably print it out, shouldn't we? Final price is 480. Hey, we got it. That's beautiful. But yeah, so let's try and run it against the real example input, right? I don't know how long it's going to take. I have no idea. Senior dev behavior. Yeah. I should have actually probably looked to see how many puzzles there were and maybe got like a what's the word I'm looking for? Progress bar or something. That might be kind of nice. Hey! That finished in really reasonable time. Lowest price is $31,065. Ready? We're gonna do it. $31,065. Please, 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 please. Let's go. Let's go. Let's go. That's the right answer. You are 1 gold star closer to finding the chief historian. What's up? What's up? What's up? What's up? What's up? All right. Nailed it. Easy. Easiest puzzle of my life. I have never done an easier puzzle. That's a lie. But nailed it. One shot. Easy. GG easy. Let's go. Let's go. Yo, I love it. We're getting W's in both chats. That's what I like to see. You're not ready for part 2? I don't think... Listen, buddy. I don't think I've ever been ready for part 2. Except for that one where I was racing Bad Cop and I accidentally did part 2. Like, I got the wrong answer for part 1 and she was like, yeah, but that's the right answer for part 2. So go ahead and save that solution. It turned out to be right. So Oh, that's funny. That's funny. Part 2. That's a huge number. Bruh. All right, well, I'm going to call it a night. No, I'm just kidding. I'm kidding. As you go to win the first prize, you discover that the claw is nowhere near where you expected it to be. Due to a unit conversion error in your measurements, the position of every prize is actually this many higher. I don't even know what this is. I'm going to show you guys what this is. Let's find out. We're going to go to the terminal, and we're going to run... Do I have commas? Yeah, we're going to echo this into commas. It's a little thing I wrote and said. Okay, so the real answer is actually 10 trillion. Cool, so it was off by 10 trillion. So I just need to... Now, I still get the same puzzle input. I just need to add 10 trillion to it. Okay, add 10 trillion to the X and Y position of every prize. After making this change, the example above would now look like this. Now, it is only possible to win prizes on the second and fourth claw machine. Unfortunately, it will take many more than 100 presses to do so. And it doesn't even... But it doesn't even give me the price. It doesn't even... So this doesn't even tell me what the price of the example input would be? It doesn't even tell me the price. Bruh, okay. This is mean. Tells me which ones are reachable, but doesn't tell me doesn't tell me the lowest possible price. I would like to have that number. You mentioned algebra way. Don't you think it could help? Oh, I don't think it could just help. I think it's going to be necessary, but I'm gonna have to figure out how to do that. Okay. CP part 1 to part 2. Vim part 2. Yeah, this is what I'm doing. I CP'd part 1 to part 2. And then I just added this. So don't worry. Nothing important's happening. You didn't miss much. Technically speaking, this should work. Are those numbers too big for Bash? Are those numbers too big? Seems fine. What am I doing wrong here? Oh, I have the limit to 100. That's why. Yeah. Let's see. You concatenate it instead of add. I don't think that's true. Where do you think I did that? I did not do that. All numbers in advent of code are below 2 to the 48. Oh, okay, cool. Cool. Yeah, and Bash should be able to handle, like, basically 64-bit integers. So, okay, so these numbers shouldn't be a problem. I mean, obviously my approach is a problem, but the number itself shouldn't be a problem. But it's because I'm limiting to 100 button presses. I can come up with limits. Add 1 trillion. Okay. Good point. That's a good call. Add 1 trillion. That is a good call. Still not going to work, but that's because I limited to 100 in each direction. Part 2 already? Yeah, but part 2 because I used a very brute force method that I don't think is going to work. So I think we need to do this. Instead of 100, 100, 100, 100. We need a local max AY. Let me think about how to do this. Max AX, max BY, max BX. So let me explain my thought process. Instead of 100 or 100, Matt or Matthew or 1T or Draxium, I don't care. All right. What's up, Matt? I like Matt. I'm going to go with Matt if that's cool. It is cool. You said you don't care. So here's what we're going to do. Because we go to 100 in each of these directions, which are nice little things, we're going to actually calculate the 4 numbers we could possibly go to. So if we are going to check the A button, the max amount of presses we could press would be, let's think about this. The max amount of times we'd have to hit the AX button is what the prize of the X is divided by how much it increments when you press that button. +1? No, floor division's fine. Yeah, I think so. So I think the max AX would be the prize of X divided by how much you move in the X direction every time you press the button once. I think that's right. Okay, so I here is the maximum amount of times we'd have to press the A button in the X direction. So this is the max AX, and this is the max BX. This is the max AY, and this is the max BY. I want to print these out. We're going to go back to how we were doing it before. And what I mean by that is we're going to break. We're only going to run one example at a time. That's what we're going to do. Okay, so instead of 100 times, we have to check this many times. This sucks. This is what If I were to do this in a different language, I wonder if I could actually do this in a reasonable time. Like, these are big numbers, but they're not astronomical. Yeah, I have no idea how far it's even getting. Let's try to print some things and just see where we are. This will never finish. This will just never finish. Because I am curious, like if I were to rewrite this in Rust, I'm not going to, but if I were to rewrite this in a compiled language that's, you know, infinitely faster, is this still doable, or is this still one of those things that would take forever? Because I mean, that left-hand side has to increment all the way through all the possibilities. It's never finishing. Like, it's just never finishing. So what I have to do is I have to find a way to mathematically represent this. I have to find what I'm looking for and how to represent it without having to worry about it. If I tried to rewrite this in Rust, I would get a borrow checker error. Yeah, well, write more Rust. You'll get better at it. You'll still get borrow checker errors every so often, but you'll get better at it and more able to deal with it when it does come up. So, like, I still get them, but at least I have a way better idea of why and what's happening. Let's see. How am I going to do this? Also, if anyone's new here, I do not want your help. If you want to throw out fun little like snippets or you want to brainstorm with me, that's totally fine. If you have solved this problem and you were like, oh, here's how I did it. Nope, I don't want that. No backseat gaming. But if you want to chill and like hang out and maybe be like, oh, maybe it'll work like this. Like, I'm cool with that. But that's all I ask. Just please don't, like, no one try and give me the solution. I do want to figure these out on my own. how would we do this? We have this math formula that we came up with. And there's going to be some math here that I just don't know. And we also have a cost function. That's a term I've heard. It sounds very official when I say it, but I have no idea what I'm saying. Yeah. You probably got all the requirements except maybe our stream. Probably. Yeah. Probably if I just start streaming more. Like now that I'm just dual streaming it, I'll probably just hit those requirements. I don't have to worry about it. Bad Cop warned you there'd be math in day 13. She did. 100%. Actually, it's funny. I messaged her and I was like, yo, down to race day 13? She was like, it's going to be math heavy. But also she's busy for a bit. So we're not going to race this puzzle. We'll race a future puzzle. But yeah, no, I was warned. And I was hopeful because part 1 was so easy to knock out. But part 2 is like, I don't even know how to approach this problem. I need a way of representing this mathematically. Because when I look at this, like, I'm just going to write things out. Like, because I just see, like, this is what I see. And, like, I don't know. I don't know where to go with this. That's how they get you. That is how part 2 gets you. See, I know this is like some linear algebra, linear thing. My instinct is to graph it. Like, my instinct, which might be wrong, is like, start doing this to it and be like, okay. Or I could solve for A and solve for B. Like, if I change these to X and Y, like, was it 95x and 22y equals this, like, or equals that, like, you could just start solving it, and then I could put like y on one side of the equation, x on the other, and then you might be able to graph it or something. I'd have to think about it. I'm thinking about ways to solve this. So for this first example, we're going to use the small numbers because it's easier to work with. And we know when we're using the small numbers that there was actually, with this first puzzle, there was only one solution that was valid for X and Y, and it was the 80-40 split. So if this is the X side, or the button A, this is all button A down here, then we know that, we know this. This is what we know ahead of time. So this is, with clairvoyance, we can see this, but this might help us abstract an answer out of it just to have these pieces of data. Let's see. Let me think about this. Again, I don't want anyone to, no one's trying to give me solutions, but I don't want any solutions to this. I'm just going to think about these, how I would do it. Here's another distraction if you want to sidetrack. Well, now that you mention it. Because I know fundamentally deep down this is a math problem. I know that. I know that this equation means something. I'm just going to represent it in all the ways I can. And I know that these numbers, we had a number that gave us a solution. I'm going to say something really stupid. Well, we take this 40 here and this 80 here, and we concatenate them and rearrange the digits in the number from ascending to descending, we get 8400. So maybe that's the logic we use. I know that's not right. I know it's not right, but still kind of seemed kind of funny to say it. What a funny comment. And before we're going to do some binary XOR nonsense for this. I'm not lying when I say this. If the answer was something with binary or XOR or any of those sort of bitwise operations, I would have the answer already. I can do that. I can't do linear algebra. Binary, XOR, all that kind of stuff, logic gates and or, that is so much easier than this to me. That's just based on my knowledge. So we know that... What am I doing here? Why do I have 90? Where did 95 come from? Did I just copy that wrong? Shouldn't that be 94? Should this be 94? Yeah, it should, right? Because it's these numbers. 94, 22, 8400. You don't need linear algebra. I appreciate it. And you know what? Honestly, that's like, I'm kind of using the term linear algebra as like a catch-all for all the math that I don't know. So I don't even know enough to know what I don't know in the math realm. Kind of off topic, but do you watch Ben Eater's videos? Yeah, I've definitely watched his videos. I think he did a whole series on writing Hello World from scratch in 6502 assembly and creating a breadboard 8-bit computer. That was super useful, super informative. I really enjoyed that. Let's see. I'm an idiot. I have no idea how to even begin solving that. Well, listen, we both are idiots then. But this is the fun. This is the fun thing about a puzzle, is sitting here and just trying to think of a solution. And now that I'm on stream, I can just talk out loud what's going on in my brain. I don't want any help on this. Remember, I've said that a bunch of times. But I'm going to throw out some ideas that I'm having. My brain is telling me that 94 and 22 are important. These are how much it'll move in the X direction when you press these two buttons. And these are our two dials we can do. How many 22s we have and how many 94s we have. And I think we need to find a way to turn these two pieces of data into one piece of data that kind of represents the two. First of all, to see if it's even possible. Because, like, let me give you an example. 94 is an even number. 22 is an even number. If this number, 8400 was odd, it would never work. No amount of even numbers will get us an odd number. So there are checks we can do like this, but we need to find a way to mathematically represent these checks. So this is where my brain is starting to say things like LCM, GCD, lowest common multiple, greatest common divisor. Again, I don't know what I'm going to do with this information, but that's where my brain is leading me. So I'm writing these down. So I'm thinking about these. Percent can do even, odd, right? I'm not sure you're asking. I mean, like if I do modular division, I can use that to determine if a number is even or odd. Yeah, I could do that. That's one quick check to see if something's not possible. But I need more than that. It needs to be more than just even or odd. I need to figure out that if. Oh, hold on. I need to figure out if 94 and 22 can go into 8400 or any multiple of them. Oh my God, wait, hold on. I'm getting there. We're getting there. I think we want greatest common divisor. I think we want GCD here, but let me think about how that would actually look. Because the numbers have to go into 8400. That's kind of like what has to happen. Doesn't matter how, it does matter how many times, but right now we just need to. That is true. 420 and 69 could be the missing key. Listen, if you guys want to, I would argue that 69 and 420 are important. Turkey, you let me down, man. You said, who wants to argue? Let me know. And this person says, I would argue that they're important. And your response is, that's true. Wow, what an argument, bro. Looks like you don't even want to argue. Totally missed opportunity to argue. And you were just like immediately folded. You were like, nah, I agree. I'm going to call you out for that. Can't argue with the facts. All right. I'll give it to you. That's pretty good. How are we going to do this? I'm going to do something really stupid. Can we make our own puzzle? Where button A moves X 1 and then moves Y 2. And button B moves X 2 and Y 1. And then the prize is at X 4 and Y 4. Because then there's a bunch of ways to do this, right? Because, yeah. There's a bunch of ways we could do this. We could move A equals 4, B equals... No, it doesn't work. Let me try something. We're going to make simple.txt. We're going to move this into simple.txt, and we're going to run part1 through simple. Regex failure. Oh, I think I had a trailing space. No, I didn't. Space. Okay. So there are 0 button combos that will get you there. Oh yeah, that makes sense. That makes sense. There's 0 button combos that will get you there. This should work, right? Yeah, so pressing each button twice. Okay. I'm lost with all this. I'm just starting out with programming, tech in general. I'm here for moral support. Listen, that's totally fair. I appreciate the moral support. We are not even in the realm of programming. We are in the realm of math. This isn't even programming. This is a problem that programming is not going to help solve. This is a problem of math and how to represent this data in a way that makes sense. So here's a very simple example. How many times I would have to press the A button twice and the B button twice in order for this to be valid. So A equals 2, B equals 2, equals solution. I don't know the answer. Yeah, it's all good, man. I have to figure out what I'm doing with my life. I'll put on some thinking music for you guys. I have no idea if that's coming through. It is. I should get like a real legit stream of this. That song is called Echoes of Solace by Dave Eddy. BC is just a arbitrary precision calculator, I think. Is that what it's called? Arbitrary precision decimal arithmetic language and calculator. Yeah, it's like a whole language for expressing math problems. So it's really nice. You can like echo like 5 plus 5 and pipe it into BC, and it just like does math for you on your terminal. Super nice. Python math module has GCD and LCM. Oh, okay. Cool. Yeah, that might be the way to do it. Do I have Python in here? Python 3. Okay. Do you just import math? Beautiful. Okay. How do you get the arguments? Is it like sys.argv? Is that a thing? I don't write Python very much, so bear with me. This might not work because they're not numbers. I don't even know how you print. I don't even know how you do this in Python. I'm gonna be honest. It's like this. It's like this, right? I'm just making up syntax, guys. Module name sys is not defined. Did you forget to import sys? Oh, yeah. Look at that. When did Python get errored color messages? That's cute. Stir object cannot be interpreted as an interpreter. Yeah, how do you turn a string into a number in Python? I can do this, right? Listen, guys, I haven't written Python in like 10 years. I can't believe I'm remembering some of this stuff. Oh, argv0 is not right. Why is there a new line at the end? Oh, ew. Does the print function in Python put a new line at the end? Ugh, Python. Python. Get out of here. Okay, cool. Seems like that's working. Cool. You can also simply print the direct function call variable name instead of formatting. Oh, can you really? Oh. I can just do like this. How does it know to stringify it? Or does it just use like a default stringify? I'm in too deep in other languages. All right, cool. We have a nice little GCD utility. I have no idea if this will be useful to us. But if it is, we can get the... I don't even know what we're trying to... I literally don't even know what we're trying to do. 94 and 22? That's the first one? 94 and 22. Those are the first X's. Does this help us at all? 2. What does that do for us? I don't even know what that does for us. Is that really the greatest common multiple? That's the biggest one? Okay. 1. Oh, that makes sense. One's odd and one's even. Yeah. Every Python object has a underbar, underbar, stir, underbar, underbar that will convert to a string. Oh, okay. So like a 2-string style like method on it. Okay. So if I did like, oh, come on. A equals 57, I could do like 57 dot stir, and this returns as a string. Oh, is it? Well, wait, no, I did A, right? Oh, it's a method. Oh, okay. Oh, okay, cool. So it actually has a method that's like 2-string. Does it have a 2-string? Oh, 2 bytes. Okay. Interesting. Cool. Learn something new every day. What does this get me? Why am I doing this? I have to think. What am I trying to solve? I have these two numbers, 94 and 22. The greatest common divisor is the biggest number that can go into both these numbers. Here's what I'm thinking. And I don't have any mathematical proof to do this, except I'm vaguely remembering high school. I believe that if this number is divisible by the greatest common divisor of it, then there's a potential that these could go into that number. Just a potential. Put it a different way. If this number is not divisible by the greatest common divisor of these two numbers, then the puzzle is unsolvable. I think that's true. So that might be a nice way to just throw out puzzles. I think that makes sense, yeah, because if you take the two numbers, the one thing they kind of have in common is the greatest common divisor. They will always increment by that. Probably a little bit more than that, but at the very least, like they will always, their step function, their step function will be at least that. So if the result doesn't even go into that step function, then it just doesn't work. Let me try this. We have a part 2 and we have a GCD utility. I'll rewrite GCD in Bash eventually, but we're just going to fork out to this Python tool to kind of get us GCD. Here's what we'll do. Check if it's possible by using GCD. So we will say we want the GCD of AX and BX. We'll just assume it passes. And then if GCD modulo PX not equal to 0, meaning there was a remainder, then echo puzzle can't be solved in X direction. Return. And then we can do this. I think this will work. Do it in the Y direction. I think this is okay. Puzzle can't be solved in X direction. Oh, right. No, that's right. because we're using we're doing the plus a trillion. Yeah. That's not right. No, I have it backwards. Okay. I just print out there a whole bunch of times. Oh, right, because it's going above 100. Okay, that's what it's doing. Okay, that's correct. Okay. So if we do this, can't be solved in the Y direction, can't be solved in the X direction. Hey, we're correctly identifying things that can't be solved. That's pretty cool here. Let's try this. These are going to be super early returns, and we're going to do the plus a trillion on it. So if this works right, the puzzle, let's see, the puzzle said in the new world, it's possible to win a prize on the second and fourth clause. So it's actually the reverse now. The second and fourth one should be possible to win, and the first and third should be impossible. So if we go ahead and run this, it says that all of them can be solved. So that's clearly wrong. Well, actually, no, right. It doesn't mean that it can be solved. Puzzle might be able to be solved. That's actually what we know. That was just an early escape hatch we had. Yeah. I remember this. Now. How are we gonna do this, man? This is brutal. We need a math function for this. Yeah, adding 10 trillion really made it something else. Have you tried using tmux? Yeah, I've used it in the past. I've even used separate panes in iTerm. One terminal. It's easy enough. Gets the job done. I don't know. I keep my setup so simple. Always there's an option to use Wolfram. There's an option. I know you're joking. There's an option to do everything. There's an option to go on YouTube and find a solution. There's an option to Google a solution. There's an option to go to ChatGPT. There's an option to go to Wolfram Alpha. There's an option. I don't care. I don't care about getting the answer to the problem. I care about solving the issue in my own brain. I know you're joking, but it's like, the solution doesn't matter to me. It's the process is fun. The problem solving process is fun. Even though it might look frustrating and some people watching, it's like, oh, I just want to give you the answer because then it'd be less frustrating for me. It's like, cool. I enjoy this whole process. This is just part of the journey. Journey. Yeah, nailed it. Journey. What? Journey. I'm just staring at these numbers and waiting for divine intervention to come, and that's a really dumb way to do it, but I actually think it's kind of working. Maybe I'm going crazy and I'm doing the thing that humans do where we start to see patterns where there aren't any. But like, there's something here. Of course, it's an even and it's always going to be 1 when it's an even and odd number. I'm thinking about this because the GCD, math guys, help me out here. The GCD of an even number and an odd number is always going to be 1, right? No, that's not an assumption I can make. No. Yeah, it's not. It happens to be for these, but like, no, I could come up with like I don't know, the greatest common divisor of like, I'm sure I could come up with something. 4 and 28, right? Yeah, okay. No, well, 28's an even number. 903. Oh, good. Yeah, good call. Good call. What just happened here? What is wrong with my terminal? What did I just paste in here? Yeah, 903. Perfect example. Thank you. 9 and 18. Yeah, perfect. Yeah, these are, yeah. Okay, cool. Yeah. Right. So what am I thinking? Math is hard. You are not wrong. I'm having some thoughts here. 84 and 17. Yeah, 67 minus 17. I don't know if this is anything. I think I'm inventing patterns where there aren't any. If I subtract one number from the other repeatedly, I don't know if it goes the other way. I was able to get 1, and 1 is the GCD. Does that get me anything? I am brute forcing math concepts. I don't think this is the right way to approach this problem, but this is what I can get without researching anything. And I do want to do this without researching something. 86 minus 17? Minus 17? Minus 17? And we get 1 again. Okay, we have 94 and 22. And this was 2, right? I think it's a 6, so that's just made up. What am I trying to accomplish? I actually have no idea what I'm trying to accomplish. I think this might be a bit hard to tease out if you don't know the requisite math concept. Yeah, I think you're right. I don't know how I'm going to approach this problem. I have a couple different ideas, but hey, Dave. Hey, everybody in chat. Give the stream a like if you haven't, and smash that subscribe button. XOXO. Thank you, Charles. You always know what to say. That's right, guys. CTA time, call to action. There's no ads on my stream, as you may have noticed, so go ahead and hit that subscribe button if you're watching from YouTube, and if you're in Twitch, go ahead and hit that follow button, because when I started the stream, what did I have, like 60 followers, 65 followers? I have 106? Bruh, I like doubled my follower count on my Twitch stream. Oh my god. Thank you all. Legends. Legends over here. Thank you. Thank you. Thank you. Maybe identify or write down what are the knowns and what are the unknowns in the problem. That is a good call. I kind of have that, but my notes have gotten a little bit wishy-washy. Yeah, so for this puzzle, we know GCD 94, 22 equals 2. GCD 34, 67 equals 1. PX is divisible by this. Py is divisible by this. So we know that much. That is cool. And we know the answer to this. Because the answer is A equals 80. B equals 40. We know that. Maybe try LCM and see if there's any new patterns. Maybe a can of worms. Nah, you're right. You're right. What is LCM? Least common multiple. How do you calculate that? I don't even know how you calculate it. Whew. All right. All right, we're back at it. Back at it. Locked in. I have least common multiple open up in a Wikipedia tab. Yeah, I think there's just a generic math concept that I'm missing here. Because, like, the idea is we have this equation, and we need to find all the values of x and all the values of y that satisfy this equation. And that's pretty easy to do when this value is 8,400. It's not easy to do when this value is 10,8,400. So whatever thing I come up with needs to work regardless of how big the number is. It just needs to be like a very simple algorithm. And I'm guessing at the end of this, I'm going to come up with some sort of generic function that spits out all of the numbers that do something. I don't know. I haven't solved this, but I think I have a hint. Do you want it? No, thank you. Appreciate it, but no. I'll let you guys know when I'm ready for a hint. They are far away from the 64-bit max, but I'm going to run out of time trying to calculate. It's just, they take so long to calculate, to try every single possibility. Unless I can get relatively close with it. Like, we have a max and a min. The min's always going to be 0. Let me think about this. I keep trying to think of ways to clean up the brute force solution to get me closer to the answer. Like, get a rough idea of how many would need to be there. Just kind of shrink the domain of possible values to something that's actually manageable. 381. So at maximum, there'd only ever be 381 button presses of 22, because that would get us to 8,400, which would mean 0 in the other direction. So we have like between 0 and 381, and then it would go like this. The worst part is I remember doing a problem very similar to this in high school, in math. Some advanced math course that I was in because I was very smart. Not anymore. Oof, that's long gone. We did a problem like this where I remember it now. Question's kind of ridiculous. But the question was like, this person went to some function, and the function was for like amputees. This is a wild example, bear with me. This person went to a function with amputees. So some people there had 2 legs, and some people there had 1 leg. And when this person was like telling their, like they came home and told their mom about it, or their husband, I don't remember who was what. But they told someone, they were like, oh yeah, I went to that function and I saw 28 legs. And the question was, how many people with 2 legs did they see and how many people with 1 leg did they see? Because if you see, like, I don't remember what number I said, 22 legs. If you see 22 legs, you might have seen 10 people with 2 legs and 2 people with 1 leg, because that gives you a total of 22. This problem is identical to it, where it's like, hey, I went to the function and saw 8,400 legs. Oh, that's crazy. Did you see people with 94 legs or people with 22 legs? How many of those people had 22 legs and how many people of those had 94 legs? That's the problem. I remember doing this problem because it was amputees and it was ridiculous. I remember it was such a ridiculous problem, but it was such a cool question. And I'm like, I'm having to pull like a Slumdog Millionaire here and like really put myself back in this day. We did something. Here's what I remember. We did this. We had this. This function was the thing that did it. But we didn't do 8,400. We did small, like we didn't start with 22. We started with like 1. And then that 1 became like a 2 and it became like a bunch of numbers between that, and I don't know how we got those numbers, and I don't even remember what it told us, but I just remember we kept using the same input in the output, and the numbers got really big at one point, but the answer was always the same. It's that problem. I know this is that problem. I don't remember how to solve that problem, but I remember seeing it. I can see it. We brought it down to a really small number, and then we brought it right back up to a big number, but you could keep bringing it up to really, really big numbers, and it didn't matter. I know this is that problem. I would have no idea how to search for that problem unless the amputee example was like everywhere. I can hear my math teacher saying, you'll need this one day, and me thinking, yeah, okay, today is that day. Listen, it's true. It's true. Oh, I'm doing my math teacher so dirty by not knowing this. Nested for loop for your X and Y, brute force it. That's what I did. I did that for part 1. Part 1 was just nested for loops where I just tried everything. Part 2, because the numbers are in the trillions, tens of trillions, it's just too hard. But I mean, like I did brute force. I don't know what else you could mean. Amputee programming bash. Yeah, I'm gonna Google that real quick. Yeah, it just takes too long. Yeah, exactly. So there has to be a way to mathematically solve this, because I remember we had a function we could plug it in our graphing calculator and it gave us this graph, and like all possible values were on the graph, and that was a way you could check if something was possible, was if you could do that. I don't remember, but I don't think I'm going to derive this math concept from divine intervention. It seems I might have to call the stream eventually. I'll call the stream eventually, but I'll keep thinking. I'll give it a real good effort. Distributed brute force, divide and conquer. Listen, I mean, it's possible, but like, I didn't even come close to getting an answer on the first one. Like, not even close. It's crazy. On the example input, I didn't even come close to an answer. So I don't think that's happening. Thought you had that willow chip, yeah. I wouldn't even know how to express this in a way that could be willowized. Oh man, I mean, maybe like I said, maybe a compiled language can do this, but I don't think brute force is the answer, unfortunately. I think it needs to be really considered at a math level. What do you do when you... This is such a stupid question. If I could go talk to like 10th grade Dave, he can give me an answer, but like, what do you do when I have a function? Like I have this, and I have this. Like, what is this function? What do I do? I truly don't know the answer to this. Yo, what's up, everyone? YouTube chat. Yo, what's up, Cena? How you doing? We knocked part 1 out of the park, and we are stuck on part 2. Try in Rusty Heat. Listen, I'm not against trying in Rust, but I feel like these numbers are just too big, aren't they? Listen, what do I have to lose? I could try it in Rust. Why not, right? It cannot be brute force in a reasonable time. I believe that. I do believe that. I still have to try it, though. Because at this point, I don't have a good other way of approaching this. So I just want to try this. This is more like just for fun, and just to see what it would look like. Um, what other ones have I done in Rust? Day 9? What do you mean 14,905 possibilities? Oh, right. No, that's right. Yeah. Gaussian elimination of simultaneous equations. Probably have to Google formulas or definitely function in Python libs. Yeah, I don't. Those are just words to me. It doesn't mean anything. Like I know that I don't know it. So when I look it up, I'll find it. Like I don't need help with that. That's fine though. Yep. I'm not even reading. Oh my god, I'm not even reading. I'm on autopilot. I must be getting tired. Probably call the stream soon. Yeah, this is just to get my mind out of being stuck. This is exactly what this is. This is just to get my mind out of being stuck and to just feel like I'm making progress somewhere. This is just for my own mental edification. Input dot trim. I don't need to trim it. Dot lines dot enumerate. Cool. Cool. I'm just rewriting the bash logic now in Rust. What is this? This is price. Cool. So I haven't used regex in a million years. In Rust, that is. Oh, you want to take a vote on how to pronounce it? It's actually, I've been pronouncing it wrong. It's actually Regeeks. It's unreachable, not a function. Oh, it's a macro. Okay, let's grab the regex out of here. There we go. We're making progress. You are all wrong. It's pronounced Steve. Yo, truest thing I've ever heard, man. Let's see. Also, I appreciate everyone just hanging out. Honestly, I know it can be frustrating if you're watching someone struggle through it and you like know the answer. I know that can suck. But yeah, I appreciate you guys just chilling and not giving me the answer. And when I do want the answer, And when I decide that I do want the answer, whenever that is, there's pretty much one person I'm going to trust, and it's going to be Dark Space. It seems like they've proven themselves as someone who can do these puzzles, understand what's going on, and can understand my mindset, and probably understands the exact concept that I'm missing. I'm sure their C++ solutions are beautiful, and to knock them out on day one is impressive. So I might be hitting you up specifically. But until that point, we're going to see what we can do in Rust. Because I'm having a good time here. How do you match regex? It's captures. Oh, you can't call it match. Match is a reserved keyword. I don't know what type that is. It might be a special regex capture type, so this print line might not work, but we shall see. Yeah. What? What am I missing here? Oh. It's because I'm trying to take ownership of it by taking it out of here. Entered unreachable code. Yep, so that's what happens. So how do we get to unreachable? I modulo 4. Oh, what am I, stupid? Whoever in Twitch chat was talking about indexing things at 1, get out of here. You've infected my brain. Hey, we're good here. How do you turn a number or a string into a number? Is it .parse? Yeah, I think I can just parse and unwrap it. That's gonna be a reference to one. Ugh, that's so stupid. Can I do this or will it take it out? Okay, we're good. I should also update my indexing to be correct. All right, so what are we doing? We need to make a thing to test. Let's just put it in a struct. Struct claw machine. And a claw machine will have an A button, which will push it in the direction of X and Y, a B button which will push in the direction of X and Y, and a prize which will be a coordinate in X and Y. That's what a claw machine will have. So let's do this. Oh, this is annoying. Let me think about how I want to do this, because I actually want to kind of do a little bit of look ahead on this. Yeah, let's just get real lazy. You ready for this? Oh, what is going on? We'll do lines dot collect. Cool. So now we have the we have a vec of all of the lines that we're going to loop over. So what we can do, we can set our pointer to 0 while I is less than lines.len. We can do this. And then when we're here, we can just put this logic here. So we can just say this, like let line 1 equal lines at I line 2, I plus 1, plus 2, line 3, and then we'll go down here. We'll do a nice little I plus equal 4. There we go. So now we can parse these just like this. So we're going to capture line 1, get the stuff we want out of it. We're going to capture line 2, get the stuff we want out of it. We're going to capture line 3 and get the stuff we want out of it. Easy enough. Cool. So now we can do this. Let, what are we calling them? A button, B button, and prize. Let A button equal a tuple of X and Y. Let B button equal a tuple of X and Y. And let prize equal a tuple of X and Y. And then we will say let machine equal claw machine. And it has 3 elements, the A button, the B button, and the prize. Don't forget a semicolon. Close this. Change this. Grab the Rust format file that you like. Put it here. Cargo format. There we go. Let machine equals claw machine. We need to actually push these machines into a list of machines. Let mut machines equal vec. Machines dot push machine I plus equal 4. So now print line found machines dot len cargo run it. Lines is not found. That's because I didn't call it lines. I called it input dot lines, and that's a function which returns an iterable, which I can collect on. Found 4 machines. That's correct. Awesome. What's up? You got an infinite loop now? Never mind, got it. Yeah, I think I got rid of the I plus equals 4, but I caught that. Rewritten in Rust. That's the way to do it, man. So now we're going to test each machine. So for machine in machines do done. I don't know. Machine dot process. It doesn't matter what we call it. Let's give it a reference to self. Cool. So now we can just put whatever here. So let's go look at what we actually need to do to process it. Okay, so we had a valid hash set, and then we looped over them, and then we looped over them. Okay. And find those that were valid in both. Okay. So this is the bash code. We're just going to port this over to Rust real quick. The stream title has become a lie. It absolutely has. We are in the 11th hour, so let's go. AX a button dot 0 plus J times B button dot 0. I should have made like a vec too, but whatever. you use %d just for numbers? I think you do, even if they're unsigned. I think that's valid in Rust. I'm overthinking this now, but yeah, I think that's fine. Yeah, then we just store that in the hash set. Then we just do the exact same thing, but this time we check the y. Let's make a hash set. We don't want a hash set. We want a hash map that we can increment. If it's not already set. Is there a way to do that in Rust? Hash map with a default value. Like a hash map Rust counter. I've done this logic before and I don't remember the code off the top of my head. Okay, I just looked up the code online. It's really actually simple. I remember doing this. Use the entry thing. I'll explain it when I get there. Yeah, so according to this, you do it this way. I wonder if there's a cleaner way to do this. There might be a get I, but then I have to put it back in to the thing. Which I probably could. I could just get it, increment it, and set it again. But I think this works. Because this is basically saying, try and get it out. If you can get it, that's good. If you don't get it, then insert 0 into it, which will return a reference to the thing anyways. So either way, I end up with a reference to it. I set it, and then the reference goes away. But I don't think that's going to work. Why doesn't this work? You could put anything as a key, right? Oh wait, what am I doing? %d. Guys, I must be really tired. Method not found in entry. Oh, you know what? I'm pulling code from 10 years ago. Yeah, it's so annoying because I've done this code before. Like, I've absolutely done this code before. Yeah, there was an entry API. But whatever, we'll just do it. In Bash? It was in Bash, but now we're rewriting it in Rust. Alright, we're just gonna rewrite it back into there. Oh. Yeah. We were getting a... Probably have to do like you could probably do like a get mud or something. I don't know. I'll look up the correct way to do this so I don't just brute force it like I've been doing it. Because this is probably annoying. It's annoying for me. You really... the keys have to be that too? When you get it? That's crazy that that's the case. I mean, it makes sense, actually. Yeah, it makes sense. Why would you give ownership to a thing that's just going to get something? Can I just do this? Yeah, I can. Yeah, because it's just an integer. We can just... I think it clones. There we go. Okay. Okay. All right. We are making progress again. Look at this. Beautiful. So now we have a hash map of all of them, and we just need to loop over the hash map and find all the ones where the value is 2. When you loop over a hash map, do you get both? I actually don't know. You do. Beautiful. Cool. Cool. So now these are the ones that are valid. Cool. Like a U32 max or something? Can I just do like a U64 max? Is this valid? That is valid. Okay. Not ideal. Probably should use some and none, but here we are. Cool. It's a lot of stuff here. But I think we got it working in Rust. So let's go ahead and run this. Yeah, I can just call enumerate on it. Right. This needs to be option, not sum. These need to be that notation. Okay. Cool, final process 480, that's correct. Awesome, so this logic works, and it works in Rust. So if we give it the real input, it gets the correct answer really quickly. Like very quickly. In fact, a lot of time is probably spent just printing to the terminal. Cool. Cool. So there's only that many. So now that we have that and it's significantly faster, the only thing we had to change was that it needs to add a trillion to each price. 10 trillion. It needs to add 10 trillion. That was the only thing that needed to change. So where we get the prices, or the prize, we can do this. There we go. Something didn't like that. What didn't it like? Let's do this. We're going to debug print the machine. Okay. Oh, right. No, this is normal. It's because we limit ourselves to 100. Right. There's no solution within 100 button presses. That's correct. It was in part 2 that we started adding different logic. We started adding the max logic. We did a GCD and we did the max logic. Yeah, okay. This is easy. So we have to do, change this. PX is self.prize.0. Delete that. Go to the end. AX is self.abutton.0. Close that. Go down. Beginning line. Close that. We'll do the macro 4 times. And now we have this. So I forget what the bash code looks like. PX BX. And then it's PY, AY, and BY. Cool. So those are the maxes. Let's format the code. Now that we have the maxes, I think we just did them in order. Max AX, max BX. Yeah. Max AY, max BY. I think this is what we did. Now this, I think this will still take a long time. I don't know how long it would actually take, but I think it'll take a long time. Obviously, we can rerun it with release and see what's happening. Yeah, Yeah, because this thing's cranking my CPU. Yeah, I don't think this is going to finish in any sort of reasonable time. But what we can do is we can print out some things and kind of figure out why. Oh yeah, we're not even like coming close. Yeah, this is just not feasible to brute force at all. I knew it wasn't, but I had to actually just write some code and feel like I was making some sort of progress. I think there's a different way to do this though, because if I know I don't think I need nested for loops here. Why am I overcomplicating this? I don't think I need nested for loops here, because if I know we're doing 0 of 1, then the amount... If I know we're doing 0 of 1 of the button presses, then the amount of button presses we need in the other one is just the total amount. The total amount subtracting how many things we have. Give me a second. If we're doing 0 A buttons, then the number of B buttons we need is prize divided by B button. Prize minus A button divided by B button. What's happening here? If we know that we're doing 0 of these, then the amount we need to do here is 8,400 divided by 22. He's learning. All it took was a different language. You know what? Here, I'll be completely honest with you guys. I love Bash. But sometimes it's hard to program in Bash. Because I'm so busy thinking about the syntax, I forget to think about it from a programming standpoint. When I'm looking at Rust, I'm just thinking of numbers. It's so much easier. If we do this 0 times, if x equals 0, then y needs to equal 8,400 divided by 22. If x equals 1, then y needs to equal 8,400 minus 94 divided by 22. And if there is a remainder, then we can't solve it. But if there's no remainder, it divides into it evenly. I'm already thinking of ways to optimize this, but I have to stop doing that. I should just think of ways to solve the problem and then optimize it later. Because I'm already thinking, if we're going to be looking at 2 different X movements, find the one that's bigger, and then we move it up by that. But okay, we're on to something. So if we're going to do this, okay, divided by the B button on X how much the X moves when you press the B button. It's like something like that. Okay, that's how many times we need to try something. Yeah. If we divide it by, if we modulo it by this, this is how many times we need to try the A button. Hold on. I'm losing it again. Watching you is actually inspiring me to go back to learning Rust and actually learn proper Bash. I'm really enjoying your content, man. Yo, appreciate it, man. Thank you. Appreciate it. Sorry, I'm deep into it, so I'm getting a little frustrated and I'm getting a little burned out, but I have renewed energy. I'm learning something here. So we know the answers are 80 and 40. Do we do anything with that? A presses and 40 B presses. I don't know if the music I would play while I'm writing code would be any good. Lock in, lock in, lock in. The price is at 8,400 and we can move 22 in the X direction. And if we move 22 times to get to that, we'll have hit the button 381 times. 381, we're below the target. 382, we're past it. Cool. Awesome. And then when we start factoring in the other button, we have less of a target. So if we hit the A button once, what is the A button? 80 something? I think it's just, is it 8? No, 94. If we hit it once, then it's not 8,400 divided by 22. It's 8,400 divided by, or minus 94, which is 8,306. 8,306 divided by 22. It's 377 and some change. Okay, and then we keep going. We will eventually get to a number that is less. We'll get to a number that can't be divided by 22. This could be easy. So let's think about it this way. Let's write this out. we're going to make an infinite loop, and we'll make a condition on the loop later. Infinite loop, and we're basically going to do a while here. We're going to take the prize, self.prize.0, which is the x prize, minus I times self.button a.0. So we're basically recreating the we're recreating this. Divided by, but we're not going to use divided by, we're going to use modulo. Modulo self.button.b.0. No, can't use the name res. So if res equals 0, then this arrangement is valid. Something. And then we do I plus equal 1. This is an infinite loop currently. So we need some sort of range. We need to bound it. We also could go out of bounds. I wonder if we should be using I64s. Because Advento code was guaranteed to fit into what, 48-bit numbers? Let's use an I64. This will just handle if we go into the negatives. We'll put the condition here. And the condition we care about is if I times self.button a.0 if this is less than 0, then break out of the loop. Obviously, we could put that in a while loop, but for now, we're just recreating a while loop. Okay, we're getting there. Yep, these will all be unreachable because I'm putting them in a to-do block. Oh, look at me. Button A, button B. I should probably be more consistent, huh? Yeah, I'm just making up syntax. Oh, we don't use this, so the compiler doesn't know what type it is. That's okay, that makes sense. We have warnings, but looks like it's gonna run. Might be helpful if we did I plus equal 1, right? Might be helpful if we didn't go in an infinite loop. Fast, but not fast enough, is it? What did we make it do? 3 million in that time? What are we even counting up to? We could also use that greatest common denominator, greatest common divisor thing to exit early on puzzles too. That is a form of whatever. Are we doing a trillion? We are. Okay. Let's just try this against the normal thing. Okay, so when we know how many times we've pressed I, we also need to calculate how many times we had pressed J. We don't have that anywhere. So how do we calculate that out of this? Oh, I guess we're doing modular division here. We could do regular division, and this should be guaranteed to be just a regular number. And we'll save this as J. I think that works. Hey, that works good. So now if we store the valid here, we can do okay. So now we just need to change all these to be the Y's. Okay. Okay, well that worked. I printed out a lot of warnings and stuff, but it worked. It's still gonna be, it's fast, but it's gonna be like that calculated the real input super fast, but it's going to be slow when I start adding the trillion things to it. Like it's still, we're getting closer. We're inching our way closer to the answer, but it's not going to be it. Like, we are stuck looking at this first machine. Now, we could filter out this machine. Pretty easily we could filter out this machine because the greatest common, the GCD trick. That is definitely a way to just throw out machines pretty easily. But, yeah, I don't think this is going to finish in any respectable amount of time. Let's see. Yeah, because I think this is counting up to what? Max AX? Yeah, like that's just, I mean, come on. It's just too big of numbers. Yeah, this algorithm's just, it's just too slow. Like there's just too many possible things to check. However, this is important. We turned a 2-nested for loop into a single nested loop. Apple, what are those? What did you just do to my webcam? Why did this make, what just happened there? I don't even know. Can you multi-thread it? Yes, you can. My problem here is that we turned it into 2 loops, but like they're not nested, which is good. We've reduced one of the nestings by using math. So I know there is going to be a way to use more math and reduce the nesting. Because here's effectively what we're doing. This is the unrolled for loop. This is what it looks like. So if we can come up with something more mathy to just figure out which ones are valid, then that would be ideal. I don't know how to... We need some sort of trick. Like I've said, I've used this in math class before, where we can tell if an equation has integer solutions that satisfy it. Because that's what we need. We need to say like, this can be solved with an integer style solution. Do you want a dark space hint TM yet? No, let me think about it a little bit longer. If you have to go, let me know. Don't feel obligated to stay. I may ask you for a hint, and I may hide your chat just till I'm ready to look at it. But no, I think I'm onto something. Let me ask you, Dark Space, is it frustrating watching me go through this? Or I'm guessing probably not. Because like if I was watching someone else struggle with it and I figured out, like that's just what it is. Like I get it. I can stay for a while. I'm on PTO. Yo, awesome. Me too. Got the next week off. Can you continue if x modulo I not equals 0? That's kind of what I'm doing. Kind of, yeah, it's basically what I'm doing is I'm just doing a like modulo here. There's just so many things to loop over. It's just too big of a number. Hopefully watching the Falcons win. Yo, that's awesome. Oh man, it's just too big of a number, but I think we're onto something because like we got rid of one loop. Any way to I plus equals something larger than 1? Yeah. Some sort of step function. I wonder if I use numbers like 10, 100, and 1000 if I could come up with a solution easier, if I could see something. Or use numbers like 2, 4, and 8. Sometimes when I just use example numbers that are like so obviously base 10 or so obviously base 2, it can kind of help you think about things correctly. In this simple example, we can see that every other one is doable. Is a pattern emerging? Is there a pattern emerging? Let's see. What am I doing? Why am I abstracting this? This won't do floating point numbers. So we'll just get the remainder. Did I do something wrong? I may have. Oh, order of operations. I did it last time too. There's a pattern. There's a pattern. What is this pattern? Is this pattern guaranteed to be here? It starts at the 4th one, index 3. And then every 11th one is valid. Is there a mathematical way to express this pattern? Okay, because here's, okay. My programmer mind is telling me wait to see until the pattern, until you see the first remainder of 0, and then count how many between until you see the next remainder of 0, and then that's your pattern. But there's probably a better way to do this. Because like that, I mean, it's 16, 10, 4, 20, 16, 10, 4, 20, 16, it's always the same. And it happens every 11. Unless my math is wrong. I mean, every 11 is, I mean, 22 is here. There's no way it's just like every half of that. It's just made up. There's no way that's a thing. Start abstracting some things. So this could be y instead, which is 5400, 34, 67. A pattern. There's a pattern. There's a discrete pattern here. $13 is where it starts, and then 80. What is 80 minus 13? 63? What is special about 63? I don't know. But a pattern is most certainly emerging. I don't understand the math behind it, but I'm a programmer. $80 minus 13 is 67. Yeah, exactly. So what 80 minus 13 is 67. What's special about that? I guess that is the y value here. What did I say? Did I say I was wrong? I might have said something wrong. Trying to do too many things at once. Yeah, 67 is right here. So the difference between them was the increment of b, and the difference between them here was 11. I said 63. Okay, thank you. Yeah. Oh my god, hold on. These incremented by 11, these incremented by 67. Wasn't the greatest common denominator of these two the number 2? And wasn't the greatest common denominator of these 1? Do you take the greatest common denominator? It's like you take whatever the increment of b is, divide it by the greatest common denominator of b and a, and that's how much you increment, and that creates all possible ones that match. There's no way that's real, right? That just sounds fake. It just sounds fake. Oh my god. It doesn't sound real, right? That sounds fake. Also, the other question, what was that initial, what's that initial blank? Do we have to calculate up to the first 0? Like, why was there 13? Are we starting? It's like we're starting somewhere arbitrarily. None of these are a problem. We can calculate this. But why? Why? I don't know why it just starts at a random point, but it doesn't matter. Here's what we'll do. This is so garbage, the code I'm about to write. We'll set a flag. And when we see this, if not first equals true, okay. This is the first time we've seen a valid thing. Once we know this, we don't increment I by 1. We increment I by the greatest common denominator, by the amount that we would increment B. And the greatest common denominator. And that gives us the answer. Here's what we're going to do. We already know this logic works. So we're just going to keep it so I don't ruin anything. All right, guys, I'm beginning to believe. Might not be the best code, but we're gonna get something. What was it counting through? Oh, we save it here, and then we don't actually break out of the loop. Okay. Let's go back to the trillion. And let's just not do that. Okay. So we found the first valid thing at 3. Now we need GCD. I looked it up in a different window. So it's really weird how it works, but we have to just import it as a trait. And now we will get the GCD method on a number. So you have one number, GCD, the other number. Don't love it, but that's how it is. Okay, that is the X GCD. So now that we have that, inker, how much we're going to increment is the self.b button at X divided by the X GCD. I wrote .x and it's .0. Method not found in I64. Does GCD not work on I's? I guess it wouldn't. This is really dirty. Oh my god. It found it at 3 and we incremented it. And we incremented by 11. That's right. Now, oh my god, and instead of brute forcing the other solution, the Y's, we just test all the X ones. We just test how many times we press the button to get the right X and the right Y to see if that gets us the right... Yeah. Okay. Let found equals found. Inker by 11. Yeah. Okay. We find the first one, and then we know what the increment is. And then we can build out what the rest of the valid ones are. So instead of let mut I equals 0, we don't start at 0. We start at what we found. And then we have to reverse engineer what the other one is. I'm losing it again. Hold on. Yeah, so now we know what this number is to start with and how much we increment it by. And we just run it through this calculation, and that gives us J. Yeah. So, yeah. Let's not even get fancy here. We're not going to come up with a break condition yet. J equals self.prize.0 minus I times self.a button.0 divided by self.b button.0. And that's the J. It's going to run forever. This mixture of I64s and U64s is causing a real issue here, isn't it? What's our stopping condition here? When do we stop? It's not right, but we're getting it. We're getting there. That's why I always alias the D type I use for these, so I don't have to worry about mismatches. Yeah, that's really smart. I think if I had started doing this maybe a couple hours ago, I'd be more strict about this. I should be doing that. It would make my life so much easier. What is my stopping condition here? Yeah, I is some number. I plus equal to increment. It's going to be like I less than one of these maxes. I guess when J goes negative. Just dropping in main on fleek today, fam. Yo, appreciate it, man. Thank you. That's so nice. Oh, what? We're getting something here. Why is it always 270? What am I doing wrong here? Oh my god. Yeah, okay. Oh, it's printing out. It's printing out something at the bottom, isn't it? That's what it's doing. Yeah, right. Right. Okay. Okay. We're doing this. So now, here's what we do. Let me write this down. Find the first valid guess. Figure out how much to increment by. Generate all valid solutions. This is what it thinks is a valid solution. So what we should also do, because this tells us how many times the A button and the B button, since we are here, check to make sure this works in the Y direction too. So in order to calculate that, we need to check if self.price.1 equal I times self.a button.1 plus j times self.b button.1. If we are here, then this was valid. Oh my God. Okay. So if we make it there, then we know that it's valid. And if it's valid, then we just want to insert it. Why don't we just make a claw machine for it? Or whatever. What are we using? A hash map? Hash set. Cool. That worked. That worked. The final price is 480. That's correct. What is this algorithm? I don't even fully understand what I wrote. I'm going to be honest. I think that's right. 31065. That's right. This algorithm works. I don't know what I just wrote. I don't know what I just wrote, guys. I'm real scared. I'm not hopeful. I'm just not. It's just gonna print out too much, I think. Yeah, I think it might still be too much to run through. Like, it's still, this is so much to run through. But a lot of it's print line, so like, there's 320 machines. This might be doable. Like, okay. Hear me out. Because we can do a couple things here. These can be done in parallel, and we did have that really cheeky way of determining if we could just skip over a puzzle real quick. I don't know if you remember that. We checked if the prize was divisible by the GCDs. So, like, we did that right away. We did, like, if self.prize.0 modulo divide x GCD not equal 0, then return none. This might break because I think I'm mixing data types. Yeah, I'm mixing data types. It's the ugliest code I've ever written in my entire life. This isn't the worst. Now, I don't know if it's giving me any good answers. This is what the price is? I have no idea what the price is when it's supposed to be done. Especially because like they didn't give me what the example should be. It's not in the actual advent of code thing. Well, that's what the final price is of the example input, but I have nothing to verify it against, which kind of stinks. But it is what it is, right? Do you still use the Dvorak keyboard layout? Yes, I do. Of course I do. Been using it for 15 years at least. At least. Want me to run mine to see what it is? I kind of do. Oh, man. Yeah, you know what? Actually, Dark Space, if you want to, if that's not too much trouble for you, I would love for you to run part 2 against the example input with the, 10 trillion or whatever, just to see what you got. I would love to see if it's my 8753186, whatever I got. Okay, give me a minute. Yo, appreciate it, man. That's awesome. If it's generic, could you test it on the part 1 question, 100 steps instead of 1 trillion? I'm not sure what you mean by that. I did test it on the regular example input, like without the 10 trillion part, and I got the correct answers. So like whatever algorithm I pieced together is kind of working. Which scares the crap out of me, guys. I'm not gonna lie. So I kind of want to thread this bad boy. What do people use for threading? It's like rayon, right? Okay, yeah, that's what you meant. Okay, cool. Yeah, I think Rust has rayon for threading, and I've used it before. It like gives you, I'm looking it up right now. It gives you some sort of like iterator. Yeah, parallel iterator. Okay. The only thing this returns is the price, and it returns, yeah, let's try it. Let's try it. Because we can do these in parallel. Like, we absolutely can do these in parallel. Why would you recommend learning NVim Vim over just using Cursor? Have you tried Cursor? I'm 3 years into coding. I'm curious to learn NVim. Cheers. I've never used NVim. I don't even know what Cursor is. I assume it's like a text editor. I don't know. I just use Vim because it's what I use. Like, that's literally as simple as that. I don't have any sort of argument for it. Dave, what you sipping on? We got 0 sugar Sprite in the house. Cranking out my 0 sugar drinks to try and I'm on calorie restriction. I'm losing weight. I'm gonna weigh in tomorrow. We'll see how much weight I've dropped, if any. It's tough during the holiday season, man. I love cookies so much. Oh my god. How do we use rayon? We need all the inputs. Oh, there's just an iter. Is it just par iter? Can you enumerate with par iter? I don't really need to do that. Yeah, because I can do par-iter. We can map. Is there a... what's up? There's like a reduce map, right? In Rust. Rust has like a... it's like a map function that filters out none. Rust has like a map function. I forget what it is. And instead of like flat map, that's what I'm looking for. Or filter map? What? I don't know now. There was something it does. Cursor is like VS Code with built-in Copilot. I've never used VS Code, and I would not want to use something with Copilot or any sort of thing. I find that stuff in my text editor distracting. I hate seeing stuff like pop up. Even autocomplete is too much for me. Yeah. So, no, not for me. I'm looking this up now. Isn't filter map? Is that what it's called in Rust? Yes. Okay. Filter map is what I'm looking for. So that will filter out the ones that don't return a thing, and this will return an iterator. So now I can just sum it, I think. I can literally just save this as what do you need for Rayon par-iter? Prelude? All good. Okay, yeah, might just be on your end, man. All right, let's try this out. Oh yeah, look at that. It's running 4 at the same time. Okay. We could probably get better output. Let's go ahead and run this. 320 machines. I don't have... Oh, it's going. It's going. Let me look over. Let's take a look at my cores. Oh yeah, all the cores are at 100% CPU. That's cool. Oh yeah. 17,000% Rust. Let's go. I am maxing out this machine. All right, we are maxing out this machine to run this algorithm that I don't even fully understand why it works. I just looked at patterns and recreated them. If that isn't the most human way of doing science, I don't know what is. And there's only 320 to test, and as you can see, it's doing like one every couple of seconds. You have 128 gigs of RAM on your Mac? Yeah, I think so. I have the, what do I have? I have the, I'll pull it up. Mac Studio, Apple M1 Ultra, 128 gigs. Sequoia, got an 8 terabyte hard drive in this bad boy. This is the top of the line Mac Studio that came out 2 years. That's what I have. Dark Space says test in the YouTube chat. Spoken like a true senior engineer. I bought 16 cores. I'm maxing all 16 cores. Listen, it's true. I paid for this. I paid for the whole speedometer. We're going to use the whole speedometer, all right? I'm not proud of what's happening here, but it's happening. Oh, your comments aren't coming through when you type in your desktop. That's lame. That's super dumb. Sometimes, I don't know if you're trying to post code or something, sometimes they can get flagged as spam. This is the most terrible thing about running a programming channel is people will post like code snippets and stuff in the comments, and YouTube's system will be like, oh yeah, that's spam. That's not how a normal comment looks. It's like, bro, we're nerds. Like, just ease up a little bit. I don't even understand how this algorithm's working. I just made it up. I just looked at patterns and just created an algorithm. Like, I might actually be upset if I get the right answer. Never apologize for brute forcing AOC. Listen, I feel that. What I should have done is I should have given each machine its own unique index and then just printed out when they were finished so we could at least kind of keep up with what's going on. Because I know it's supposed to hit 320, but like, how many of you guys think have gone by so far? Like, I don't have the answer to that. I don't know. It does not like the large number for part 2, I think. Ah, darn. That's okay. I mean, it is what it is. If you want to, if you can, like, Pastebin or, GitHub Gist or something, you don't have to. Don't feel like you have to. 875 billion. Oh, okay. Well, actually, did I clear my output? I may have cleared the output. Yeah, I did. Well, I can just run it again. Doesn't hurt to have 2 copies of this running. Hey, 875 and then a whole bunch of stuff. Let's run that through commas. Yeah, that's 875 billion. Yo, let's go. I don't even understand how my algorithm works, bro. Oh, it's not printing any more machines. The thread pool is draining. We're almost finished with this. I just looked at patterns and was like, oh, okay. Once I find a remainder of 0, we incremented by how many B button presses divided by the greatest common denominator. What? Guys, what is this? What is this? If this works, I do not understand why. If this works, I have no idea why it works. I've been streaming for over 5 hours. My brain is fried. I don't understand it. I don't get it. I don't understand how it's right. I'm losing my mind. You gotta be kidding me. That's amazing. I'm so happy, but like, I truly don't understand. Like, you guys saw what I did. I just looked at all the possibilities and was like, oh, this first one hits a match arbitrarily, and then they all seem to just, every 11 or so spaces there was a match. What's that number 11? Well, the number 22 and the number whatever and their greatest common denominator is like divided by that. I'm like, it doesn't make sense. The algorithm doesn't make sense. I need a mathematician to like sit me down, hold my hand and be like, you were so close, Dave, but here's how it works. Because that should have, the only reason that worked is because I paid for a lot of cores on my machine.